The last thing new we need to talk about here is vertical stretching. Vertical stretching takes every point on the parent function and multiplies the y value by a constant. So for example, if you have y equals k times the parent function, that keeps all of the x values the same and multiplies just the y values by k. So it's a little harder for people to visualize and a little harder for people to handle. So we're going to take the time to really stop and talk through that a couple of times. So you can see down here that this function, the original f of x here, whatever that is, it takes and it leaves the x in the same place, multiplying it by k, and it stretches it up to here. Now it's only going to technically be a stretch if k is greater than 1. If you multiply it by a half, it doesn't actually make the y value bigger, it makes it smaller. So vertical stretching technically only occurs when you multiply the outside of the function by a constant that is greater than 1. So you might want to take a couple of notes on that. We'll add that to our list here. And if we have k times f of x, we get a vertical stretch if k is greater than 1. And it's actually called a shrink, a vertical shrink, but you can still call it a stretch. It doesn't matter. You can call it a stretch or a shrink. It's technically called a stretch if k is greater than 1, a shrink if k is a fraction between 0 and 1. So if k is like a half or a third, it actually shrinks it. You really kind of have to understand what this does. It leaves the x values alone, but multiplies the y value by k. And that's what vertical stretching and shrinking does. Technically, they're all called stretches, but it confuses students when it gets smaller instead of bigger. So we'll just kind of let you see it, and I think it'll make sense to you. There is a type of thing called a horizontal shrink or a horizontal stretch where you put the k value on the inside of the parentheses, but Heinz has decided that we're not going to cover that, and so I'm just going to leave it out as well, unless you guys are just dying to do it. Are you dying to do it?
No.
You're okay leaving it out? Okay, so these will be the only ones that you have to know. Vertical translations, horizontal translations, reflections, and vertical stretches, or stretching. Let's pause for a second, let everybody take their notes. So returning to our main flip chart here, it's actually a stretch. The y values will get bigger if the constant you're multiplying by is greater than 1. But you can see from this slide that these y values are actually getting smaller. If you look at the blue here, graphed in blue, if we multiply by a k that's between 0 and 1, that's a fraction less than 1, it actually drags the y values down some. It cuts them in half or cuts them in a third or something like that. So it actually makes it look shorter, and sometimes it even makes it appear fatter, I guess. It's kind of the way it looks to me when that happens. So it makes it look fatter when you multiply by a fraction, skinnier and thinner when you multiply by a number greater than 1. Let's take a look at a couple of examples. Let's do both of these. We're going to do on the same graph. They're going to have the same parent function, so that we can kind of look at them together. So let's look at g of x equals 2 absolute value of x, and h of x equals 1/2 absolute value of x. For part A, what's the parent function?
Square root of x. Absolute value of x.
Y equals the absolute value of x. Now that's the parent function for both of those, correct? Yes? Okay. Are there any vertical or horizontal translations? No. There are no numbers added or subtracted anywhere. Are there any reflections? No, there's not a reflection. There's no negative sign. The only thing is there's a constant multiplied on the outside of the absolute value here. So this is actually called a stretch of 2. And this one is actually called a stretch of 1/2. But a lot of books will call that a shrink. So stretch or shrink, it doesn't really matter to me what you call it. You can call it either one. as long as you know it's 1/2. Let's go over here and let's graph just the parent function. Here's our parent function. And let's see what we need to do to get part A graphed. To understand stretching, you have to remember that you keep your x values wherever they are right that minute, right that moment. Keep the x value, but multiply the y value by your value of k. So for this one, this is the point, 0, 0. Do y'all understand that? Okay. If I keep the x, it will stay at 0. If I multiply the y by k, what does it become?
0.
Still stays 0. Let's make sure you understand that. It started off at 0, 0, that point did. Then I multiplied the y only by 2. It still stayed 0, 0. Okay, let's move on to the next point. The next point right now is at negative 1, 1. Negative 1, 1. If you multiply the y value by 2, it will be at negative 1, comma 2. So it actually moves it up to there. So make sure you understand. At the point negative 1, 1 was the original. Then I multiplied the y value only by my k value of 2. And it became 2. So that's why I relocated that point to negative 1, comma 2. It's kind of hard to do in your head. I have to come out to the side sometimes and actually make a list of ordered pairs so I can see it happening. Okay, then I'm going to take the point negative 2, 2, negative 2, 2, and multiply its y value by 2, and I will now be at the point negative 2, comma 4. So negative 2, 2, multiplied by 2 becomes negative 2, 4. So you can see it's getting skinnier. Okay, can y'all see what's happening now? All right, let's go do the other 2 points. This point is 1, 1, so it will become 1, comma 2, and this one is 2, 2, and it will become 2, comma 4. There's the graph of y equals 2 absolute value of x. Personally, I think that stretching and shrinking is a very difficult way to graph. So if I'm given the choice, I will probably just make a table for those rather than do translations. But you could do either. But it's important to understand the difference. You know, what does that 2 do? How does it make it look different? It makes it steeper, right? And kind of grabs these points and pulls them up, each one of them, by a factor of 2. All right, now let's take those points and let's redo it for a stretch of 1/2. Let's redo it for a stretch of 1/2. Let's see if we can do that. Well, obviously 0, 0 is going to stay the same, right? What's the point 1, 1 going to do? Instead of 1, 1, it's going to go to 1, comma 0.5 or 1/2. Instead of 2, 2, it's going to go to 2, comma 1 because it's halving the points. Same thing over here. Negative 1, 1 gets halved, and negative 2, 2 gets halved. So it actually makes a much wider graph. It takes those original red dot values and it shrinks their y value down, making the actual graph look bigger. So here's a problem that doesn't have really anything new to it, but it's kind of interesting. Rather than giving you actual equations, they give you a graph and they say, okay, here's your parent graph. All right, and we want you to make 3 changes to the parent graph. The first one, we want you to just add 2 to the end. Well, adding 2 to the end is going to take that parent graph and shift it where? Up 2 units. So regardless of what the graph looks like, it's going to take those 3 points that are on it, move them up 2 units. So let's go ahead and let's kind of sketch that over here with this guy. This moves it all up 2 units. That's called a vertical translation. Let's do that one first. Goes to here, goes to here, and goes to here. So there is part A. So there's the graph of A. Any questions about that one? Talk to me about B.
Right.
B is going to move everything to the
Right.
good, right 2 units. Thank you. So it's going to go back to the original and take the original graph and shift it to the right 2 units. To the right, to the right, to the right. So there is graph B. So it's letting you look and make sure you understand the different things that can be done to this. Finally, part C takes every point on the original, and what does it do? It stretches the y values by 2. We said the stretch is 2. So it multiplies the y values by 2. So for the original, this point will stay 0, 0. But the point 1, 1 will become 1, comma 2. And the point 2, 2 will become 2, comma 4. So it actually makes a weird, like, bigger graph right there. And that's part C. So the last thing we need to talk about before we call it quits on section 3.4 is what to do if you have multiple things being done to one equation. And believe it or not, the order does matter. Now, it doesn't always matter for vertical and horizontal. Those don't matter really. But if you've got reflections and you've got stretches in there, the order can really kind of mess you up. So you need to always do these in this order, typically. Horizontal, so first we're going to do the left or right. After you move it left or right, then you're going to stretch or shrink. Okay, that's when you're going to multiply your y values. What does the reflection do? Do that third. The reflection is where it, basically in kind of just layman's terms, that's where it flips, right? Do any flip you have there. And then the vertical translation moves it up or down. And that's what you're going to save for the very end. So I usually try to remember it as just an acronym, HSRV, HASRAB. So if I have multiple things, that'll help me just make sure I do them in the proper order. So horizontal first, left or right, then you stretch, that's where you multiply your y values by a constant. If you need to, if you have a reflection, do it third, okay? And then if you have a vertical translation, do it last. So save your vertical translations for last. You would never believe it, but the up-down really can mess things up. That's where it actually gets into trouble there sometimes. Do y'all know why? The up or down is the only one that's not connected to the main piece. You know, like it's kind of off to the side. It's not multiplied in front. The negative is, you know, and then the like reflections are and the
It's not on 0, 0.
right, yeah. So it's kind of been moved strangely. So it really affects it differently. Okay, let's do one last example. Let's take the parent graph y equals absolute value of x, and let's use it to graph y equals 3 absolute value of x minus 2 plus 4. So we're going to do 3 different things. It doesn't have all 4, but it has 3 different things. Let's make this graph a little bit bigger so we have a little room to work. We can see it a little better. Okay. Now, first off, what's my parent graph?
Y equals
Absolute value of x.
Y equals the absolute value of x. Okay? Then I want you to list the different things. Horizontally, what's being done to it?
Right 2.
All right. Is it being stretched?
Yes.
By what?
3.
Has a stretch, and it is getting bigger, by 3. Is it being reflected?
No.
So we'll just say there's none there, which is nice. And finally, is it being moved vertically?
Up
Up 4.
Up 4. Those 3 things have to be done, and that's the order they need to be done in. So let's go off to the side over here, and let's get a basic parent graph going. Y equals the absolute value of x. You should be getting really good at these parent graphs. Okay, and let's do those 3 things to it. We're going to take all 5 of those points, move them right 2, stretch their y values by 3, and then move them up 4. Ready? Here we go. All right. Let's start on this point. First, I move it to the right 2 units, which brings it to here. Can you guys see that? Then I need to multiply the y by 3. What's the y right here? What y value is that? 2. So if I multiply it by 3, it becomes, so instead of 2, it moves to 3, 4, 5, 6. So now I'm here. Can you guys see that? Then I need to still move it up 4, which is kind of weird. 1, 2. I don't like it either. My graph is going to be way up there. Don't you agree? Yes?
That's not even the highest point.
I wish I made it bigger. How could I fix it?
Go up by 2.
But even then, that's huge. Well,
Change the plus.
would you guys mind if I just do it, it'll just be up in the white air up there? Will that upset you? No? Okay, good. All right, so move it up 4. 1, 2, 3, 4. We'll just pretend. So we're way up there now, which, whatever. But that is your highest point, Sarah.
Oh, I thought that was the same.
Yeah, it's not that. It was this point. So it's not going to be any worse than that. So that's okay. Okay, now let's try this one. Let's go to the right 2. 1, 2. Stretch by 3. So it will now become a y value of 3. Because we're at 1 now. Goes to 3. Then it moves up 4. 1, 2, 3, 4. I have a lot of trouble when there's a stretch in the middle. Stretches are the hardest for me. I don't know about you guys. There's my second point. Let's take our third point. We're on this point right here. To the right 2. Stretch by 3. Well, 0 times 3 is still 0. Then move it 1, 2, 3, 4. We finally found our vertex. That's our new vertex. So then we're going to move this point next. To the right 2, stretch by 3. 1 times 3 is 3. Then move it up 4. 1, 2, 3, 4. And now you can start to see the symmetry coming back. And finally, this last point, right 2, stretch by 3, which relocates it to 6. But then I have to still move it up 4 units. 1, 2, 3, 4. So I'm up here in the white space, but we've decided we're just not going to worry too much about it. There is my final graph right there. So you can see it has been moved to the right, it's been shifted up, but it's also been made skinnier. And that wraps up section 3.4 finally.